Somewhere past the edge of the solar system, a machine older than the internet went quiet, and for a moment, NASA feared it had lost one of the most important objects humanity has ever built. This is the story of how Mission Control almost lost contact forever with a spacecraft that has been flying since the 1970s, and what happened in the tense days that followed. It is a story about distance, about aging hardware pushed far beyond its warranty, and about engineers refusing to give up on a machine that has already outlived nearly everyone who built it. The spacecraft in question is Voyager 2, one of two twin probes NASA launched in 1977 to explore the outer planets before pushing on into the space between the stars. By the time this particular scare happened, Voyager 2 had already spent decades in flight, and it was sitting more than 12 billion miles from Earth, deep in interstellar space, far beyond the orbit of Pluto and well past the protective bubble the Sun casts around our solar system. At that distance, a radio signal traveling at the speed of light takes over 18 hours just to reach the spacecraft, and another 18 hours for any reply to crawl back to Earth. Every single command has to be planned with that delay in mind, because there is no room for a quick correction if something goes wrong, and something did go wrong. During a routine series of commands sent to the spacecraft, ground controllers made a small mistake, one that would have seemed trivial on any object closer to home. The command caused Voyager 2's antenna to tilt just 2 degrees away from Earth. 2 degrees might sound like nothing, but across 12 billion miles of empty space, already faint after traveling so far, vanished from NASA's receivers, and Mission Control was left staring at silence where a steady stream of data used to be. For the teams at the Jet Propulsion Laboratory, this was not a minor inconvenience. Voyager 2 is one of only 2 human-made objects that have ever reached interstellar space, and it carries scientific instruments that cannot be replaced or repeated by any other mission currently flying. If contact could not be restored, decades of irreplaceable data collection would simply end, and one of the most celebrated spacecraft in the history of exploration would drift into the dark, alone, and unreachable, forever out of humanity's grasp. Engineers scrambled to figure out what options remained, and the answer was not encouraging in the short term. Voyager 2 does have a built-in safety feature for situations like this. Several times a year, its onboard computer automatically resets its orientation to make sure the antenna points back at Earth, a kind of built-in course correction designed for exactly this scenario. The problem was timing. That automatic reset was not scheduled to happen again until mid-October, which meant NASA was potentially facing months of total silence from a spacecraft it could neither see nor speak to, drifting through the void with its ear turned away from home. Rather than simply wait out the calendar, engineers at the Deep Space Network decided to try something bold. They aimed one of their most powerful antennas at the tiny patch of sky where Voyager 2 should be, and they sent an extremely strong signal in the spacecraft's direction, hoping it might be picked up, even with the antenna misaligned. NASA described the attempt informally as trying to shout loud enough across billions of miles that the spacecraft might hear it despite facing the wrong way. It was a long shot, and nobody was certain it would work, because nothing on this scale had ever really been tested under these exact conditions. While that plan was underway, the Deep Space Network kept listening for any sign of life. On August 1st, after days of receiving nothing but empty static, a very faint signal appeared. It was not a full data stream, and it did not carry any usable information, but it was unmistakably a carrier wave, the kind of steady radio hum a functioning spacecraft transmits even when it is not actively sending data. Engineers described it as something like a heartbeat, proof that Voyager 2 was still alive and still broadcasting, even if it could not yet hear anything being sent to it. That faint pulse, arriving after so much uncertainty, was enough to shift the mood at Mission Control from dread to cautious hope. The heartbeat signal confirmed the spacecraft had survived, but it did not confirm the antenna had been fixed, and NASA still had no way to send new commands or receive full telemetry. The team kept working, refining their approach, and continuing to monitor every scrap of signal that came through the Deep Space Network's giant dishes scattered across California, Spain, and Australia. Each of those facilities plays a role in tracking spacecraft that have traveled far beyond where any single ground station could reach. Alone, and in this moment, all of them were focused on one aging probe drifting through interstellar darkness. Then, less than 2 weeks after the mistake first severed communication, NASA announced something remarkable. Full two-way contact with Voyager 2 had been restored. TE spacecraft's antenna had realigned enough for both commands and data to flow normally again, meaning the probe could resume its normal science operations and continue sending back the kind of information that no other mission in human history has ever collected from that region of space. Project manager Suzanne Dodd, who has overseen the Voyager missions for years, said the outage was believed to be the longest gap in communication NASA had ever experienced with Voyager 2, and admitted the scare had rattled even veteran members of the team. To understand why this moment mattered so much, it helps to remember exactly what Voyager 2 represents. Launched just weeks before its twin, Voyager 1, The spacecraft was originally built to study the outer planets, and it remains the only spacecraft ever to have flown close to all four of the solar system's gas and ice giants: Jupiter, Saturn, Uranus, and Neptune. After completing that historic planetary tour, Voyager 2 kept flying, eventually crossing the heliopause in November 2018 and officially entering interstellar space, joining its twin as one of only two human-made objects to ever leave the protective bubble surrounding our sun. Both Voyager spacecraft are powered by radioisotope thermoelectric generators, devices that convert the heat from decaying plutonium into usable electricity. That power source has kept them running for nearly 50 years, but it decays steadily over time, and engineers have had to make increasingly difficult choices about which instruments to keep powered and which to shut down permanently in order to stretch the mission further. Dodd herself has said the team has become remarkably resourceful over the last decade, finding ways to squeeze every last watt out of systems that were never designed to last this long, in hopes that at least one of the twin probes might survive long enough to reach the 50th anniversary of its launch in 2027. This scare with Voyager 2 was not an isolated incident either. It arrived alongside a string of other worrying headlines about NASA's aging fleet of spacecraft. Around the same period, NASA lost contact entirely with MAVEN, a Mars orbiter that had circled the red planet for more than a decade, studying its thin upper atmosphere. MAVEN had been functioning, normally right up until it passed behind Mars as seen from Earth, and when it emerged on the other side, controllers heard nothing at all. Unlike Voyager 2's temporary scare, MAVEN's silence stretched on for months, and NASA eventually declared the mission over, ending more than 11 years of continuous atmospheric research and communication relay work for the agency's Mars rovers. Spacecraft failures like these are rarely sudden or mysterious. Once engineers look closely at the underlying causes, long-duration missions tend to fail in a handful of predictable ways. Fuel eventually runs out, reaction wheels used for pointing. The spacecraft can seize up after years of constant motion. Electronics slowly degrade from decades of exposure to cosmic radiation, and power sources like plutonium generators fade on a schedule that can be calculated years in advance. Of all these failure modes, the slow fade of nuclear power is considered the most predictable, because engineers can watch the wattage drop month by month and estimate, with real accuracy, roughly when a probe will finally go silent for good. That is precisely what happened decades earlier to Pioneer 10, an even older spacecraft that first crossed the asteroid belt and became the first human-made object to fly past Jupiter. In January 2003, a faint radio whisper reached a giant dish in Madrid after traveling roughly 12 billion kilometers across the vacuum of space, taking more than 11 hours just to arrive. It turned out to be Pioneer 10's final transmission. 2 weeks later, when controllers reached out again, they heard nothing but background noise, and the spacecraft's dwindling power supply had finally dropped below the threshold needed to send anything coherent back to Earth. Pioneer 10 remains out there today, a silent, tumbling relic of 1970s engineering, drifting endlessly toward the distant star Aldebaran on a journey that will take more than 2 million years to complete. It is a quiet reminder of what eventually awaits every spacecraft humanity sends beyond the reach of easy repair, no matter how carefully it was built or how many records it managed to set along the way. Seen against that backdrop, the brief loss of contact with Voyager 2 takes on an even heavier weight. For nearly 2 weeks, NASA did not know whether one of its most historically significant spacecraft had joined the growing list of missions lost forever to distance, aging hardware, and the simple passage of time. The successful recovery was not just a technical fix, it was a reminder of how fragile even humanity's greatest achievements in space exploration really are, hanging by threads of radio signals stretched across billions of miles of silence. It is worth remembering that this was not the first time Voyager 2 had gone quiet on NASA. Back in 2020, the spacecraft went silent for roughly 7 months, while its primary communication antenna on Earth underwent major upgrades, leaving engineers unable to send any commands at all during that stretch. That earlier gap was planned and expected, but it still left the team on edge, since a spacecraft this old could theoretically develop a fault at any moment with no way for controllers to intervene. The 2023 scare was different because nobody saw it coming, and that unpredictability is exactly what makes aging spacecraft so nerve-wracking to manage from Earth. Voyager 1, the older of the two twins, has faced its own share of frightening episodes as well. In November 2023, the probe suddenly began transmitting a repeating pattern of code that made no sense, effectively babbling instead of sending usable data back to Earth. Because Voyager 1 is roughly 15 billion miles away, any single round of troubleshooting takes nearly 2 full days to complete, since a command takes over 22 hours to arrive. Engineers had to dig through decades-old paper documentation written by people who designed the spacecraft's systems long before anyone imagined it would still be flying half a century later. After months of patient detective work, the team eventually traced the glitch to a single corrupted chip in one of Voyager 1's onboard computers and found a clever workaround that restored normal communication. These repeated near misses highlight just how remarkable it is that either Voyager probe is still operating at all. Both spacecraft were originally designed for a mission expected to last only about 5 years, focused primarily on flybys of Jupiter and Saturn. Nobody on the original engineering team could have reasonably predicted that these machines would still be sending data home nearly 50 years later, let alone that they would become the only human-made objects to ever leave the solar system entirely and begin sampling the true interstellar medium. Every additional year of operation is now considered a kind of bonus round, squeezed out through careful power management and a willingness to sacrifice less critical instruments to keep the most valuable ones alive. NASA's broader fleet of aging spacecraft tells a similar story of machines running far past their original expiration dates. The 2 remaining active orbiters at Mars, Mars Odyssey and the Mars Reconnaissance Orbiter, have both been circling the red planet for more than 2 decades, well beyond what their designers originally expected, and both now show their age through worn-out reaction wheels and thinning fuel reserves. Meanwhile, missions like the International Space Station have experienced their own brief communication blackouts over the years, reminding engineers that even spacecraft in low Earth orbit, just a few hundred miles from home, are not immune to sudden and unexplained silence. For now, both Voyager probes remain alive, still transmitting, still teaching scientists new things about the strange region of space that lies beyond our sun's influence. But every engineer working on the mission knows that time is not on their side. The plutonium keeps decaying. The instruments keep shutting down one by one to conserve power. And somewhere, out past the edge of everything familiar, 2 aging machines built before most of their current caretakers were even born continue drifting into the unknown, carrying humanity's questions further into the dark than anything else we have ever built, waiting for the day when even the faintest heartbeat finally goes silent for good.